Hi guys. So today what you're going to do is going to start with your new notebook. So make sure you get a copy from the front. Topic 2, Section 1, how are symbols used to represent substances? So now we're going to start to look at the symbols and look at the way they combine and bond. So we're just going to skip past page 2. And we're going to look at our first focus question, how are the elements represented? So on the video, I'm not going to take the time to fill in all of these, but I do want you to do that. So you can stop the video, go get the information, and come back. So basically, if we look at atomic number 1 and we look at our periodic table, we know that atomic number 1 is hydrogen, and the symbol is a capital letter H. If we go to atomic number 2, we can see that it's lithium with a capital L, lowercase I, and so on. Okay, I want you guys to go ahead and fill all that in, but you don't need to watch me. So then I want you to think about, what do you notice about the way the elements are and the way they are represented? So what you should notice, and we've talked about before even in 8th grade, is that there's either one capital letter or a capital plus a lowercase. Never two capitals. Okay, which kind of leads us down here. So if I have CO, if I look up, that is element number 27, which is cobalt. But if I have capital C, capital O, now the capital C represents carbon and the capital O represents oxygen. So it's a compound combining carbon and oxygen. So it's actually carbon monoxide that you may have heard of if you have a wood stove, things like that. Okay. So one capital, never two capitals. It could also be a capital and lowercase. And you will also notice that we've talked about already something like silver is an SI, it's AG. We use the Greek and the Latin names. And then diatomic, we have talked about a little bit already, but bring it back up again. So diatomic means that they're elements that always exist in pairs. So I had you color those in on your reference table. There's 7 of them that are diatomic, and they make a 7 on your table. So when we colored them in on your table, they were nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and then the weird one all the way over here, hydrogen. Okay. And we would represent them, so we'd have H2, and then we have N2, O2, F2, Cl2, Br2, I2. Okay. All right, so now that's kind of stuff we've already pretty much known. The next piece, we did cover this in 8th grade, but kind of a little bit more now. So thinking about what the chemical formulas tell us. So they tell us the element, but what else do they tell us? So what information does a chemical formula tell you? So if we look at NaCl, there's qualitative information. Spelled that wrong. And quantitative. So quantitative has to do with the numbers of atoms, and qualitative has to do with which elements. So in other words, for NaCl, qualitative would be that it's Na and it's Cl that are combined together. Quantitative would mean that there's one Na and one Cl in the formula. Okay. All right, so if we look at NH3, it tells us that we have nitrogen and hydrogen. We have 1 nitrogen because there isn't anything there. We have 3 hydrogens. That little subscript tells us that we have 3 of the hydrogens. So in other words, we have 4 atoms total in that molecule. Okay, so 2 different elements, 1 atom of nitrogen, 3 atoms of hydrogen to make a total of 4 atoms to make this one compound. Okay. All right, we're going to skip this one for a minute. We're going to come down to copper sulfate. So Cu is one of the elements. That's copper. And then notice that the S is capital and the O is capital. So that means we have sulfur and then we also have oxygen. There's only one copper, one sulfur, and then this little 4 goes with the O. So there's 4 oxygens. So we have 4 atoms of oxygen, 1 atom of sulfur, 1 atom of copper. So we have a total of 6 atoms that make up that molecule or that particle. And then there's 3 different elements that make it up. So 3 elements, 6 total atoms, 4 oxygen atoms, 1 sulfur atom, 1 copper atom. All right, so then we're going to look at what it means when we have a big number out in front. So when we have a coefficient, we have to distribute, just like you would in math class. So we have 5 waters, basically. 1, 2, 3, 4, 5. Well, that gets kind of a pain to write up, right? So we got 2, 4, 6, 8, 10 hydrogens, and we have 1, 2, 3, 4, 5 oxygens. Well, that gets to be kind of a pain, so we just take our 5 and we distribute it. 5 times 2 is 10 hydrogens, and 5 times 1 is 5 oxygens, and you can jump right to here. Okay. So if we look at this one now, we distribute the 3, so we have 3 magnesiums, and we have 3 times 2, which is 6 chlorines. Or in other words, we have MgCl2, MgCl2, MgCl2. We have 3 of the whole thing when it's a coefficient that's out in front. And then that would give us our 1, 2, 3 magnesiums and our 2, 4, 6 chlorines. And then our last one, 4 NAs, 4 N, because the N and the O are capital, and 4 times 3 gives us 12 O's. Okay? All right, you guys have a quizzes practicing the intro stuff. Let me know if you have any questions.